Hi, today we are going to learn about atmospheric pressure. Okay, so it is similar to air pressure, it's the same thing. Okay, now let's look at the girl here. Can you see? She is drinking. She is drinking chocolate milk. Okay, when she suck in the air inside the straw, okay, she will create a low pressure inside the packet of milk. All right, when inside the packet of milk is lower, what happened to the outside? The outside will be stronger. It will push the packet. That's why the packet looks shrink. She did not squeeze it actually. Okay, all right, so inside the packet will be like a partial vacuum. Air particle inside will be forced out. These create low pressure inside. So as I said, higher air pressure outside, the atmospheric pressure will press onto the packet. Okay, I repeat again, the air pressure outside, okay, is the atmospheric pressure. Okay, now let's look at the application of the concept of air pressure in our daily life. And one thing teacher would like to remind you, okay, air or any particles will move from high pressure to low pressure, to the area of low pressure. Okay, now let's look at the plunger. Okay, can you see the plunger? All right, so look at this. Okay, so this is the plunger, one of example of air pressure, the application of air pressure. How do you use the plunger? Okay, first you push the plunger. All right, when you push it down, what happened to the air inside? It will be forced out and creating a low pressure. And then at label 2, as you pull up at number 2, okay, the space inside there will become bigger. So when the space is bigger, so what happened? So the air pressure, okay, will be reduced. Now let's look at where is the higher air pressure. The external air pressure there. When the air pressure inside the plunger low, the atmospheric pressure inside the pipe will be higher. So teacher repeat, the high pressure in the pipe, okay, will push out blockage when the plunger is pulled up. Okay, so this is how it works. Okay, now let's look at Madgeburg Hemisphere. Okay, what is hemisphere means? Okay, is a half of sphere. All right. Okay, you put them together. You put the two hemisphere together, and you pump out the air inside. So air inside the hemisphere. Look at this. It is pumped out. When it is pumped out, what happened? What happened to the pressure inside the hemisphere? It's zero, right? So meaning zero pressure. So these two hemispheres cannot be separated. Why I said so? Because when it is zero pressure inside, so what happened to the pressure outside? Okay, so the pressure outside, so-called atmospheric pressure, will become strong, very strong. It will exert a very strong force on the hemisphere. Okay, that's why, okay, you can see, okay, it will be glued together, very strong. Okay, you cannot really separate it. It's like glued together. This is because of the pressure from the atmospheric pressure outside. It push the two hemisphere. Okay, now let's look at the third example. That is the straw. Okay, when you try to drink, okay, as you suck the air, all right, okay, you suck the air to your mouth, what happened? Okay, so you will create low pressure inside the straw. So when it is low pressure inside the straw, okay, can you imagine that the pressure outside, that is atmospheric pressure, will become stronger. So what happened? It will push the water to the straw. Okay, now let's look at example number 4. This is Syphon. Get a tube filled with water and then put the tube, the label B inside the picture. Okay, must be lower than the level, the labeled A. Okay, all right. When the water flows out, it will create a low pressure inside the tube. When it is low pressure, the atmospheric pressure, okay, in the outside will push the water, okay, into the tube. Alright, so it will push the water out, and it will flow continuously. Okay, now let's look at example number 5. Shrink. How does shrink work? Okay, nurse will pull the piston. Pull up the piston. What happens when it is pulled? Okay, the volume of the air inside the cylinder will increase. When the volume increase, what happens? Remember, teacher explained to you. Pressure will be lower. Okay, volume increase. Okay, so pressure will be lower inside. So what happened to the outside? So air pressure outside will be higher. This is the atmospheric pressure. Look at the label 2 there. So it will push the liquid into the shrink. Very easy. All you need is to identify where is the low pressure, okay, and where is the higher pressure. Okay, so of course, as I said just now, okay, air particle will move from higher pressure to low pressure. Let's look at the vacuum cleaner. So what happens, okay, in every vacuum cleaner? So there'll be a fan inside the vacuum cleaner. So this fan will push air out, will suck out all the air inside, okay, at the level 1. Okay, so this create low pressure. Okay, in other words, air is sucked out and create low pressure at level 1, as it creates space, more space, as air has been sucked out, right? So that part will be lower pressure, and what happened? Okay, of course, the atmospheric pressure outside will be higher. Okay, teacher repeat again, yeah. Low pressure created at number 1. Okay, inside the picture. Okay, so what happened when there's low pressure? So of course the outer pressure, okay, or atmospheric pressure, okay, as you can see at label 2 there, okay, will be higher. So when it's higher, it will push the dust inside the vacuum. Okay, so this is how it works. So higher atmospheric pressure outside will push the air and the dust into the vacuum cleaner. Alright, now let's look at example number 7. This is very important, especially when you are in form 3. Okay, alright, let's discuss. Okay, only one hole. Okay, what happened? Actually, the milk will not flow easily. Why I said so? Because it will due to the high pressure outside the can. Because why? As you pour the milk, okay, there'll be lower air pressure inside the can. So when there's a lower pressure inside the can, the outer pressure or the atmospheric pressure outside will be higher. So it will push the milk back into the can. That's why you need to poke another small hole. You need to poke another small hole. A can of condensed milk with 2 holes. Okay, so what happened? The milk will flows out easily because air pressure inside and the outside is equal. Okay, so teacher repeat again on this. Okay, so when you poke 2 holes, okay, so you will create an equal pressure inner side of the can and also the atmospheric pressure. Okay, do not forget that. Yeah. Okay, now let's go to Kebab question.